recording there?
It's got a pause button. Yeah, it's got a pause button. So
Are you seeing the timer going off at the top?
Yeah.
Okay, then we're good. All right. So, how far did you get? Where did you said you couldn't get it in the slope-intercept form?
Yeah, I just didn't know how to start it.
Okay. So, you take the first one. Pretend it's like an equation just for a second. The whole idea is to get into y equals mx plus b, right? So I need to move the x, so I'm going to subtract x. So far, so good? That makes sense. Remember the negative that's in front of the y. Divide through by that -1. -1. Is that better? So what was the rub? Like, where were you? Oh, hey, there. What was throwing you about it?
Well, I tried to subtract the x, but then I didn't put a negative y or a negative x.
Okay, so you did start out here. You didn't put like a negative y, so you had like negative x plus 1.
Trying to erase it all.
All right, so that's the first equation. Look, the second one. How do I convert it? Ugh, that's horrible. Let me rewrite that.
I think you can subtract that.
Yeah, subtract x again.
That's what I meant by moving.
Yeah, you should have to write a line there.
Huh?
Divide the whole equation.
Whole thing by 4, right. There you go. Be careful with this right here. When you say negative x over 4, do not make it negative 4x. Don't do that, because that's two different when you say negative 4x, you're saying negative 4 times x. But what's going on right here? Dividing. Right. So it's really negative 1/4 x plus 5. Okay, so now they're in a little bit nicer form. So to go to we'll graph one, then we'll shade, then we'll graph the other one, and then shade it. Okay? So we'll do the first one. Okay? So now looking back at the original inequality, should it be solid or should it be dashed? Dashed. Close enough. All right. Which side should it shade?
Oh, we shade to the left.
No, to right. I got it right.
Addie, how do we do it?
I got y, that means 4x over 1.
We're talking about shading right now.
Oh, well,
How-
I didn't get to that because I knew I got it in wrong, so I didn't shade.
It'd be on the right side.
Well, tell me from here. Let's pick up from here. So that equation, that line, how do I determine which side to shade?
It's false.
What you said was right. Yeah, like take 0, 0, plug it in. Pick a test point. So go back up here to the top. Is 0 greater than 1? No. So this test point, we plugged it in, it proved false. So that means I shade on the other side. Okay, we'll do the next one, we'll do it in a different color. 1, 2, 3, 4, 5. Drop 1, 2. So dashed again. So we'll pick that test point 0, 0 again. That all gives me 0. Is 0 greater than 20? No. So I'm not going to shade on this side of that dashed line. I'm going to shade on the upper side. So it's going to shade this way. So if we're just looking just for the solution region, I don't even really care about this or this. The solutions lie in this region. Now, that's actually, it looks like a small region, but if you think about it, the graphs are going on forever and ever. So basically, anything in this expanse, it would satisfy as a solution. Does that make sense? Yes?
So could you have done this standard form too?
Well, yes, but one thing you would have run into with these would have been this. So like your x-intercept would have been 20, your y-intercept would have been 5. Where's 20?
That's
Right.
what happened to me. So the lines is still looks the same, but doesn't go.
It could have worked. You would have had to like scale these differently, maybe make them worth like 2 or something. So how many lines are there? 1, 2, 3, 4, 5, 6, 7. There's only 8 of them. So you'd have to play with your scales a little bit. But yeah, you could have. It's just, so with something like that, if you see that your graph is going to, you can see really quick that's going to run off the graph. That's why you might lean towards the slope-intercept form. That's why I did it anyway. So, did anybody try 5 and 6? This is a good time to try this then. So let's pick up. I'm going to give you about 5 minutes. So number 5, I'm going to take that first equation, or inequality. Well, I'm pretending it's an equation, right? So subtract x. 2y equals negative x minus 6. Right? Okay. Divide by 2. Oh, x. How are we? Yes, no. What'd you get?
I had negative to begin with.
Well, like the net. You move the x over here, right? You got to change the sign, so that makes it negative. You got a positive 2 when you divide by it. That's what makes negative 1 half.
Well, I know what I did wrong. I just.
All right.
Yeah, I didn't realize.
So it's this thing right here, right? That.
Yes, I put it as negative 1 half. You gotta stare at it for a minute.
Oh.
Went back over it.
Oh. All right. So look at the other one.
Today is not
Yeah, look at David's answer up there.
Okay, one more question before we move on.
Okay.
Okay, this may sound dumb, and you probably said it before.
Probably.
But I'm just throwing the long ball here.
Go ahead.
Why do we move the 4 all the way out? That's something I don't understand.
Because you're trying to get y by itself.
Right. I'm trying to take this is in standard form.
Yeah.
I'm converting it over to slope-intercept form. So like like on the wall over here, y equals mx plus b, right? Y is isolated. The x term is over on the other side of the equal sign, right?
Yeah.
That's why. That's why I'm moving that thing over there.
Okay, so it would make it 4x. Like on the y, I'm even talking about the 4x.
Yeah, so it was negative 4x.
Yes.
To move it from here to here, you're going to cross the equal sign, right? So I have to negate this, right? Make it go to 0 to move it over here.
Oh, okay, I got it. Okay, got it. Because trying to get y by itself, so you're trying to move it on the other side.
Yes,
I'm
yeah.
still dumb.
No, you ain't done. It's late in the afternoon, right? All right, so your 2 equations graphs. I'll do this one first. 1, 2, 3, 4. Yeah, 5. All right, going back. So I'm looking at this one. Dashed or solid? Dashed. So there's your line. So got to test which figure out which side to shade on. So we'll use the origin again. All of that right there goes to 0. Is this statement true? No, this is false, right? So we took 0, 0, we plugged it in, it proved false. I shade on the other side then. Okay. Are we all in agreement so far? Making sense? No? Where am I losing you? Okay. Okay. Well, we need to figure out what's. So, do you have the same equation that I have? Okay. Let me ask. Did you do this? Did you go up here to 5? Did you count like down 2, maybe back this way? Okay, that's the issue. Okay. What you're doing is this. You're taking this, and obviously you know that's negative 2 over 1. You're buddying the negative with both of the numbers. Is what's happening. Because based on what you told me, you're dropping down 2, which means a negative 2 direction, and you're going back 1. Negative 2 over negative 1 is a positive 2. You see how that line's doing this? That's a positive slope. That's a negative slope. Does that make sense? So when you see that, that's like saying negative 2 over positive 1. You're still dropping down 2. You're moving 1 in the positive direction. Okay? All right, so our other one now. So negative 3, 1, 2, 3. Drop 1, run 2 this way. All right, so we test that point again. We test 0, 0 in there again. Is 0 less than negative 6? No, 0 is greater than, right? So I'm not shading this side. I'm not shading on this side of this line. I'm shading here. Yeah, so basically, yeah, this little area right here, that's the area that they all cross.
I actually think I can do this now after that one. That was the only thing stopping me.
Did anybody get to number 6? Yay or no?
We did. No, we got stuck.
Did? Okay. All right.
What should we do?
So, Addie, what did you get for your equation on that top one? Top equation. Or inequality, sorry. What was when you converted it over, what did you get?
1 plus 4 is.
Y equals what?
I think I'm wrong.
So you subtracted 4x. Right. Oh, wait. Say what you said. You said 1, what?
1 plus 4 fifths.
Plus 4/5 x. Yeah, right. That's it. Yeah, good. Very good. So you subtract the 4x. So you have negative 5y equals negative 5 minus 4x. Divide by the negative 5. That's it.
You got the
So, so that's dashed again. So test 0, 0. Is 0 greater than negative 5? Yes. So it's shading this way. And then what does this line look like, though? This is a little bit sneakier. There you go. It's straight up and down. So it's a dotted line too, right? This way or this way? this way, this way. This way?
Yeah.
Okay, so it's shading all this way. So the overlap, that's your overlap.
Like that line in the middle, that represents 4, 5.
This line right here,
No,
this one,
yeah.
this right here, y is less than negative 1
Okay, I'm sorry, I was just.
because it's vertical line. Okay? Yeah. Any more questions on that before I move on? All right, so you got to flip the page. All right, so let's look at some word problems. Love me some word problems. All right, so big picture here. What's going to happen is we're given a situation, and we're going to model this situation with a system of inequalities. So instead of it being just arbitrary, meaningless inequalities graphed on the graph because the teacher said to do it, these are going to have actual context to them. So let's read through it and just kind of get our head wrapped around it. So you have somebody, they're in a Boy Scout camp. He's selling popcorn to raise money. Not too hard, right? So he's got two options here. He's got small bags worth $4, large bags worth $6. And there's two thingies he's looking at here. One, he needs to earn at least $300. So, key word. What kind of inequality is that? Greater than, less than, greater than or equal to, less than or equal to?
Greater than or equal to or less than or equal to. One of those.
Which one?
Oh, greater than or equal to.
Okay, because at least 300, right? He can make 300. He can make 4 million. If you make that much selling popcorn, we need to talk, because I'd like to know your secrets. All right, so we know that right out of the gate. And it says he will also earn a badge if he sells 60 bags, at least 60 bags. So there's that term again. So on our paper, you might want to be writing these little clues down.
Yeah, I think we already have all. Yeah, I think we have more than just that.
Huh?
Yeah, mine got something.
Did we do this the other day?
No, I think this is how you print the.
Yeah, I think you forgot to erase it before.
Really? Well, now you're going to figure out where it all came from. I did not realize it was like that. Merry Christmas. Never say I didn't give you something. All right, so. All right, so my first inequality there, let me explain to you how I did it. So I'm going to have one of them representing the actual money being raised. So for the small bag, I just call that X. At least I think. You tell me. It's on the paper, I guess. All right. So that's my X. The large bag is going to be Y. So don't worry. There's some coming that I haven't written down. So not on that page, but on one of them. All right. So, but let's make sure we understand the meaning of it. $4 per small bag plus $6 per large bag. This needs to be at least $300. Does my logic make sense? Okay. So my second one, I'm writing another one because if he sells small and large bags, and if he exceeds or at least makes $60, he gets a badge. I guess he's going to feel good about himself. He got a badge. So I've got these two inequalities here. We need to figure out how to graph them on that graph given. So what are some things we need to consider before graphing it? Okay, so what do y'all think? So you're saying go ahead and convert it over to slope intercept? Okay, why don't y'all go ahead and do that real quick? Because I didn't do that on that paper. Ha. This one, convert it over. What do you got? Good, Addie.
Y equals 50 negative 2/3 x.
50 minus 2/3 x. All right, what about the second? Somebody else.
60 minus.
Y equals 60 minus x. Okay, so when we look at it, I don't have 60 spots here, do I? So I need to scale it. So how can we scale the y-axis to accommodate 60?
We can go by 5.
Will that be enough to cover it?
Um,
Yeah. Like if I go by 5, is that enough?
16 of them.
There's 16 of them? Okay, so 5 and 16, that should be plenty. What's that, 80? 5 and 16 is 80. So, okay. Go ahead. No, I mean, do you have to do it by 5s? No, but it's you could do it by 10s, couldn't you? I mean, if you could do it by 20s, right? You'd have plenty of space left over. So, what about our x's then? How should I scale it? Really, there's no wrong answer here. I will say this. If it's ever possible to try to keep the relationship of the x and the y a 1-to-1, because make sure you understand what I mean by that. If I just go over this graph and I say, where's that on the x-axis? You would say 1, right? And if I said this is 1, right? All right, so it's like a 1-to-1. If you do like 2, 4, 6, 8, and this is 1, 2, 3, 4, you have to be careful because when you're counting your slope, it'll mean differently if it's not 1-to-1. You got to pay attention to it. It's not wrong. It's just you got to watch what you're doing. So make sure you go through, label your axes. We're going to do it by 5s as well. I should be labeling the axes right now. Make sure you label what they represent as well. So what are we letting the x-axis represent? Small bag. So the y-axis would be. So we'll make sure we. So now we're actually we've got context to this. These values are going to mean something. So let's go y'all go graph your lines.
What is the numbers on the side?
Huh?
The numbers on the side. How do you go by
These 5s.
5s?
Yeah, going up by 5s, going up by 5s. So y'all should be able to graph these, do the shading and all that. So I'm gonna let you go at it for a minute. So, but it should be close. Pick 0, 0. We're doing the same skills that we was using before. Okay. So tonight, this one right, I want you to finish it. And since obviously I got the other one set up for you, try that other one as well. Okay. Hey, let me make sure this thing's